I am Mr. Manideep Gupta, Assistant Professor, Department of Aeronautical Engineering from MLR Institute of Technology, Hyderabad. Today, we are going to discuss about the topic gravity. In yesterday's class, in the previous class, we discussed about the basic principles which are required and basic fundamentals which are required to understand the space and space propulsion. So, today, in that, we are going to discuss about the topic gravity. Coming to the overview of today's topic. We discuss about the gravity. What is gravity? Universal law of gravitational force, calculation and its application, and the importance of gravity. Let's come to the gravity. What is gravity actually? The gravity is nothing but the basic attraction force between any two bodies in this universe due to their mass is called gravity. Okay, this is nothing but a basic attraction, fundamental attraction force between any two bodies in this universe. You take any two bodies, the basic fundamental attraction force between these two bodies due to their masses is nothing but called as gravity. So, it can be between any two bodies, like it can be between sun and earth, it can be between earth and moon. The gravity, it is a force between the earth and moon due to their masses, and everyone knows the basic like example which we take for gravity, that is apple. Okay, even the attraction force between the earth and the apple, whatever the force between this earth and apple, that is also gravitational force. And you can see two persons here, and there is a force between these two person. Okay, there is a force between these two person, that also gravity. Basic attraction force between any two bodies in this universe due to their masses is called gravity. So, this person has some mass m, this person has some mass m2. So, these two person will have some gravitational force of attraction between each other. So, this can be possible for any objects, any two objects you can take in this universe. So, how do you understand and how do you calculate this gravity, and how do you apply this gravity? So, this is explained by Newton, universal law of gravitation force. So, in that he explained that you can consider the two bodies, like here this is body m1, this is second body which has mass m2. Okay, so this is m1 and m2 are the masses of the objects, and because of these masses, according to the gravity, okay, there will be some force between these two objects, that is gravitational force. And let's say the distance between the centers of these two bodies is small r. Okay, in this case, the gravitational force is calculated with the help of this formula, F is equal to capital G into m1 m2 by r square. Okay, so actually the gravitational force is F is directly proportional to the product of the masses of two bodies, and it is F is inversely proportional to the square of the radius. Okay, so if you take these two things, then finally F will be capital G into m1 m2 by r square. And what is G here? G is the gravitational constant, universal gravitational constant, and G value is 6.674 into 10 to the power of minus 11 meter cube kg per meter cube per kg second square. 6.674 into 10 to the power of minus 11 meter cube per kg second square. So, this is the universal gravitational force F. So, whatever the bodies you take in this universe, if the bodies has mass m1 and m2 and the distance between the two bodies is r, the centers of the two bodies is r, then F will be capital G into m1 m2 by r square. Okay, this is universal law of gravitational force. So, how do you apply this and how do you calculate this? So, calculation and application. So, let us calculate the earth gravitational force on other objects which are on the earth. Okay, so let's consider here earth and one another object. So this is your earth, and we consider one object, okay, another object, that is nothing but we consider a small ball, and the mass of this small ball is 1 kg. Okay, and the mass of earth is 6 into 10 to the power of 24 kgs. Okay, mass of the ball is 1 kg and the earth is 6 into 10 to the power of 24 kgs. So let's calculate the gravitational force. So first we need the formula. That formula is F is equal to capital G into m1 m2 by r square. m1 is the mass of the ball here, m2 is the mass of the earth, and r square is the distance between the centers of these two bodies. Consider this is the center of this ball, and consider this is the center of the earth, and this is nothing but the radius, the distance between the centers of two bodies. So if you consider the size of the ball is very small and we can neglect the size of the ball, then the earth radius, the distance between these two earth and the ball, we can consider that as radius of the earth, that is RE. Right. So here formula value of G is 6.674 into 10 to the power of minus 11, and mass of earth is given here 6 into 10 to the power of 24. This is the approximate value, and this is 5.972 into 10 to the power of 24 kg is given. And radius, we need one more parameter called radius. This is mass of ball. Okay, this is mass of ball, this is for earth, and this is the distance. So here this is nothing but radius of earth. So what is radius of earth? Radius of earth we discussed in the last lecture. We discussed about the mass of the earth, radius of the earth, mass of the different planets, and radius of the different planets, revolutionary periods, all those. From that data we got these values. Okay, so if these are the values, then we calculate the F. What is F? F is equal to capital G. What is the value of capital G? 5.972 into 10 to the power of 24 kg into m1. m1 is the mass of ball, that is 1 kg, and m2 is the mass of earth. Right? What is the mass of earth? This is the mass of earth. What is that? Let's calculate the gravitational force. Okay, earth gravitational force on the object called ball now. Okay, F is equal to capital G. Capital G is 6.674 into 10 to the power of minus 11 into mass of the ball, that is 1 kg, into mass of the earth, that is 5.972 into 5.972 into 10 to the power of minus 11 divided by radius of earth, that is 6371 into 10 to the power of 3. We convert this into meters whole square. So if you do this, okay, if you do this, you will get this is equal to 9.8 Newton. We will get 9.8 Newton. So this is the earth gravitational force, that is 9.8 Newton. 9.8 Newton on a mass of ball which is 1 kg. So this is the gravitational force on the ball. And what is the distance? The distance is radius of the earth. So generally everyone knows what is this. Sometimes everybody remembers this value 9.8. That is the value of small g also. Small g is equal to 9.8 meter per second square. Everyone know this. Attraction, gravitational attraction force, acceleration due to gravity. Then what is the difference between this F and small g? Small g, these units are newtons and small g units are meter per second square. These two are different. Okay, and if you consider the same earth, okay, if you consider the same earth and the mass of ball is moved to a distance of 1000 km altitude. How much? 1000 km altitude from the radius of earth. Then how to calculate? The same procedure. F is equal to capital G into mass of the ball, mass of the earth, divided by the distance between the earth and the center of the ball. So here this is the radius of the earth plus 1000 kilometers extra. So it will be 6371 plus 1000 kilometers, that is the altitude of the ball, into 10 to the power of 3 whole square. So if you do that, you will get the gravitational force of attraction on the same ball of 1 kg, that is equal to 7.35 newtons, which is at 1000 kilometer altitude. See here, if you take the ball on the earth surface, you got the F is equal to 9.8 newton, and if you take the ball at a distance of 1000 kilometer from the earth surface, you got 7.35 newton. Why this? Because force is inversely proportional to the distance between the two objects. That's why as the distance between the objects increases, the force will decrease. As the distance between the object decreases, the objects come closer, the force will increase. Okay, this is how we calculate the force of attraction, gravitational force of attraction between any two bodies. Like this, you can calculate the attraction force between any two bodies. Here we have taken earth and ball. Like this, you can also calculate the attraction force between the earth and other planet called Mars, or we can calculate the attraction force between the earth and moon also. If you know mass of the earth, mass of the two objects, mass of the earth, if you know the mass of the moon and distance between this the earth and moon, easily we can calculate the gravitational attraction force between this earth and moon. In the same way, we can calculate the attraction force between any other objects in this universe. So what is the importance of gravity? So gravity is very necessary, right? Gravity makes us to explore the space. Okay, it is a key to space exploration, and we can analyze the forces acting on bodies in the space with the help of this gravity, and you can analyze the relative motion of the bodies like planets, asteroids, satellites, etc., which are in the space, and which helps in interplanetary landing, observation, etc. The earth atmosphere is also because of the gravity only. Whatever the atmosphere we have around the earth, that is also due to the gravity only. And the gravity itself holding the solar system. Okay, the solar system is together, is holding by the gravity, and it determines the weight of object. Okay, the weight of object changes from one planet to another based upon the gravitational force of that particular object, planet. And this gravity itself shapes the universe, and it is the foundation of physics. Finally, it governs the structure and behavior of the universe at all scales. So gravity is the basic foundation for the physics. So this is about today's lecture. So the topics which we discussed are gravity. We discussed about the gravity, universal law of gravitational force, and we have gone through how to calculate this gravitational force and where do we apply this and the importance of gravity. So this is about today's lecture. Thank you.